Hi all, I am here with my new video on chapter 10, Reduction, Oxidation and Electrochemistry. Let's start. In this video, we will learn how to balance redox reactions. For balancing redox reactions, two methods can be used, half reaction method and the ion electron method. Half reaction method. Redox reactions can be balanced by identifying the elements that are oxidized and reduced and then writing their half reactions. Let us consider a reaction where copper reacts with nitric acid and make copper nitrate, NO and H2O. There are 7 steps in this half reaction method which are following and we can explain them using above equation. First step is rewrite the equation with its oxidation numbers. So we write copper and every element with their its oxidation number. Second step is identify the elements that are oxidized and reduced. In this reaction you can see copper is oxidized, its oxidation number is changed from 0 to +2. Nitrogen is reduced, its oxidation number is changed from +5 to +2. Next step is write the oxidation and reduction half reactions. For this reaction, we can write oxidation half reaction and reduction half reaction like this. Then next step is multiply each half reaction by appropriate number so that the number of electrons lost by oxidized element is equal to the number of electrons gained by reduced element. This step is necessary because electric charge must be conserved. So we will multiply oxidation half reaction by 3 and reduction half reaction by 2 so that the total number of electron lost by oxidized element is equal to the number of electrons gained by the reduced element. Our fifth step would be add the two balanced half reactions eliminating the electrons. We call the result the balanced skeleton redox equation. Our sixth step is insert this coefficient from the skeleton into the original equation by matching each element and its oxidation number. There is one exception. Do not insert the coefficient of any item that appears in more than one place in the equation. Since nitrogen appears twice, we do not insert the coefficient for it. Last step is balance the rest of equation, the non-redox part, by inspection. So our equation would be 3 copper molecule reacts with 8 molecules of HNO3 and makes 3 molecules of copper nitrate plus 2 molecule of NO plus 4 molecule of H2O. This is our balanced redox equation. The next method we use to balance redox reactions is the ion electron method. In this method of balancing redox reactions, we do not have to assign oxidation numbers for individual elements. We consider the equation where copper reacts with nitric acid and makes copper nitrate, NO and H2O. First of all, we stripped off all the items that do not participate in oxidation and reduction. Cu plus NO3 minus arrow, Cu2 plus NO. We balance for both mass and charge in a step-by-step fashion. First step, separate the equation into half reactions by selecting similar items on both sides of the arrow and we get Cu arrow Cu2 plus NO3 minus arrow NO. Balance these half reactions for all atoms that are not hydrogen or oxygen. The copper and nitrogen atoms are already balanced. For third step, we will balance the half reactions for oxygen by adding one water molecule for each oxygen atom needed. Add the water molecules to the appropriate side of the half reactions. Fourth step is balance the half reactions for hydrogen by adding hydrogen ion for each hydrogen atom needed. Add the hydrogen ion to the appropriate side of the half reaction. Our fifth step is balance the half reactions for electric charge by adding electrons to appropriate side of the half reactions. In next step, multiply the half reactions in order to conserve electric charge. The number of electrons lost must be equal to the number of electrons gained. In our seventh step, add the half reactions but eliminate the electrons. If H2O or H plus appears on both sides, subtract the smaller amount from each side of the equation. The resulting equation is now balanced and it is like this. 3 copper molecule plus 8H plus 2NO3 minus arrow 3Cu2 plus 2NO plus 4H2O, and this is our balanced redox equation. Voltage. We measure the energy output of electrical devices in relation to the amount of charge they transfer. This quantity is known as potential difference or voltage, and its SI unit is the volt. Under standard conditions, the zinc copper cell would have a maximum voltage of 1.10 volts. As the cell continued to operate, however, its voltage would drop and finally became zero when the cell reached equilibrium. Oxidation and reduction potential. For each reduction half reaction, a standard reduction potential, which is one type of standard electrode potential, has been assigned. Its symbol is E0 and is also measured in volts. The more positive a reduction potential is, the more easily the reduction half reaction associated with it can occur. Standard oxidation potential. For each oxidation half reaction, a standard oxidation potential is assigned. Since an oxidation half reaction is the reverse of a reduction half reaction, the standard oxidation potential is simply the standard reduction potential with its sign reversed. The following example illustrated this principle. Maximum standard cell voltage. There is a formula we can use to calculate the maximum standard cell voltage, which is represented by E0 cell. E0 cell is equal to E0 reduced minus E0 oxidized, or E0 cell is equal to E0 cathode minus E0 anode. In our next video, we will learn about the standard hydrogen half cell and electroplating. To watch new videos, please subscribe and like.